In lesson 5.8, we're learning about the rational zero theorem. So if you want to write this down in the box, here's how the rational zero theorem goes. First, you find the constant. So the constant for number 1 is negative 49. Find all the factors of, and we'll just do 49. The factors of 49 are 1, 7, and 49. The only ways to make 49 are 1 times 49 and 7 times 7. So the factors of 49 are 1, 7, and 49. Then you go to the leading coefficient. So the leading coefficient is an invisible 1. So the only factor of 1 is 1. So then you take this list and you divide by that list, and that's a short list, and you put plus or minus in the front. So the possible rational zeros, according to this theorem, are plus or minus 1, plus or minus 7, and plus or minus 49. Alright, so notice the key word is possible. There are, in that list that I boxed, there are 6 possible numbers: positive and negative 1, positive or negative 7, positive and negative 49. That doesn't mean they're all going to work. Only 4 of them, at the most, could work. Okay, so the steps are, you take the factors of the constant, then you find the factors of the leading coefficient, and then you divide the numbers on the right by the numbers on the left. So I'm going to do number 3 next. The factors of 21 are 1, 2 doesn't go in, but 3 does. 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, and 7 because 3 times 7, and then 21. Alright, the leading coefficient is 6. So the factors of 6 are 1, 2, 3, and 6. So I'm going to take the numbers on the right and divide by the numbers on the left. So we're going to have, and also remember to put plus or minus in front of each one. So plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. All right, so far I've divided all of them by 1. Now I need to divide all of these by 2. So plus or minus 1/2, plus or minus 3 over 2, plus or minus 7 over 2, plus or minus 21 over 2. And now I'm going to divide them all by 3, plus or minus 1/3. I'm not going to do 3 divided by 3 because I already have 1 on the list. Plus or minus 7 over 3. And then I don't need to do 21 over 3 because that's 7 and we already have that. And now I need to divide by 6. Plus or minus 1/6. Plus or minus, we don't need 3 over 6 because that's 1/2 and we already have that. So next is 7 over 6. And then 21 over 6 reduces to 7 over 2. So that's it. All right, I'm going to do the evens now. Okay, so constant is 5. Factors of 5 are only 1 and 5. Leading coefficient is 2. Factors of that are 1 and 2. So it's going to be a short list, plus or minus 1, plus or minus 5. And now divide them by 2. Plus or minus 1 over 2, plus or minus 5 over 2. So remember, it's the list on the right divided by the list on the left. Okay, factors of 11 are 1 and 11. Factors of 2 are 1 and 2, so another short list, plus or minus 1, plus or minus 11. And now we have to divide them by 2, plus or minus 1/2, plus or minus 11 over 2. So again, these are possibilities. They won't all work. And now we're going to figure out which ones actually do work. So on number 5, it doesn't say find the possible, it's find all the rational zeros. So you can start out by listing the possibilities. Let's do that. So factors of 28. So I'm actually going to divide them by 1. So I'm not going to bother with 2 lists. I'm just going to go straight into the final list since I'm just going to divide them all by 1 anyway. Okay, plus or minus 1, plus or minus 2. 3 does not go into 28. 4 does. 5 does not go in. 6 does not go in. And now I'm just going backwards. 4 times 7. 2 times 14. And 1 times 28. Okay, so these are the possibilities. We need to find out which ones actually work. All right, now if it's factorable, you should just factor it, but this is not factorable. I can tell this is not factorable because the ratio of these two numbers, or of those two coefficients, is 1 to 4. The ratio over here is negative 25 to negative 28. Those are not equivalent, so this is not factorable by grouping. So what you have to do is do synthetic division and guess which ones are going to work. So if I set up my synthetic division, I'm going to have 1, 4, negative 25, and negative 28. So I have to guess from my list what's going to work. So I'm just going to guess that negative 1 works. So I plug in negative 1, bring down the 1. 1 times negative 1 is negative 1. 4 plus negative 1 is positive 3. 3 times negative 1 is negative 3. Add negative 25 and negative 3, you get negative 28. Multiply negative 28 times negative 1, you get positive 28. So something is a factor if it goes in and leaves no remainder. So negative 1 is a factor, it's a 0. Okay, so if you don't get a remainder of 0, then you just have to guess again. All right, now once you find the first answer, you don't have to keep guessing usually because, all right, so look at the original degree. It was to the third power. So now we know that this is called the depressed polynomial. It's called depressed because it has a degree that's 1 lower than the original. So x squared plus 3x minus 28. And when it's x squared, when the degree is 2, that's called quadratic. And we've learned a few methods for solving quadratics. You can use factoring, you could use graphing, completing the square, quadratic formula. This is factorable, so let's use factoring to find the other two rational zeros. So x plus 7, x minus 4. If we solve that, we get x equals negative 7. We also get x equals positive 4. And then don't forget the answer we got earlier by guessing, negative 1. So there are 3 rational zeros. And the degree was 3, so we know there are no other zeros. All right, for number 6, I can see that factoring by grouping will actually work because if you look at the coefficients, that's a 1 to 6 ratio. 4 to 24 is also a 1 to 6 ratio. So I'm not going to waste my time with the rational zero theorem. I'm just going to factor it by grouping. So first group, I can take out x squared, leaving behind x plus 6. Second group, I can take out a positive 4, leaving x plus 6 in the parentheses. The directions said find the zeros, so we're going to equal it to 0 and solve. X squared plus 4 goes together. X plus 6 goes together. So if you solve this one, you get negative 6. And that's our answer because if you solve the other one, so if I solve this equation, and I square root both sides, if I solve that equation, I get plus or minus 2i. The directions said find all the rational zeros. So the only rational zero was negative 6. Okay, for number 7, we're going to have a really long list because 60 has a lot of factors. I'm going to do just one list again because the list on the left is just 1. So I'm going to go straight to the final list. 1 goes in, 2 goes in, 3 goes in, 4 goes in, 5 and 6 both go in. 7 does not go in, 8 does not go in, 9 doesn't go in, and we're just going backwards now. 6 times 10, 5 times 12, 4 times 15, 3 times 20, 2 times 30, and 1 times 60. All right, when you have a super long list like that, I would just recommend looking at the back of the book and seeing what answer works. On a test, we're not going to give you a list that long because then you might not finish the test because you'll waste so much time trying to figure out which one works. So let me set up my synthetic division. All right, I'm going to try positive 3 and we'll see if that works. Bring down the 1. 1 times 3 is 3. 2 plus 3 is 5. 3 times 5 is 15. Negative 11 plus 15 is 4. 3 times 4 makes 12. 8 plus 12 is 20. 3 times 20 is 60. And then we have 0. All right, so sometimes if the original degree is to the 4th, you have to guess again. Sometimes you have to do this. You have to go chop off the remainder and then guess again. But we actually don't have to do this for this problem because if you look at the coefficients, factoring by grouping will work. We have a 1 to 5 ratio, and that's a 1 to 5 ratio multiplied by 4. So factoring by grouping will now work. So I rewrite my depressed polynomial. The degree is going to be 1 lower than it was. So it was x to the 4th. It's going to be x to the 3rd now. So I have 1x to the 3rd plus 5x squared plus 4x plus 20. And so now I take out x squared from the first group. I can take out positive 4 from the second group. We're finding the zeros, so that means set the equation equal to 0 and solve. So it's x squared plus 4 times x plus 5 So if I solve this one, I would get -5. If I solve this one, I would get plus or minus 2i. So making my list, we found 3 by guessing, -5 we found by factoring, and then we have the 2 imaginary. Right, the original degree was 4, and we found 4 answers. And the directions said find all zeros. It didn't say rational zeros, so we included the imaginary ones. On number 8, we have a pretty long list. We have factors of 54 are 1, 2, 3, 4 doesn't go in, 5 doesn't go in, 6 goes in, 7 and 8 don't go in, and then 9, we're going backwards. 6 times 9, 3 times 18, 2 times 27, and 1 times 54. Factors of 4 are 1, 2, and 4. Right, so the list would be plus or minus 1, plus or minus 2, plus or minus 3. So everything on the right gets divided by 1. Everything on the right gets divided by 2. I skipped 2 over 2 because that's 1. So I'm actually just going to divide all the odd numbers. The even numbers, we already have those in our list. 18 divided by 2 is 9. I already have that. 54 divided by 2 is 27. We already have that. And then same thing for 4. I'm just going to divide the odd numbers by 4. 2 over 4 is 1/2. We already have that. 6 over 4 is 3 over 2. We already have that. 18 over 4 we already have. 27 over 4 is our last one. Okay, that's another really long list. So we're going to guess from that list. So again, on a test, we're not going to give you a list this long. So I'm going to guess -2, and if that doesn't work, then I'll just have to guess again. So I'm going to guess -2 and hope that the remainder is 0. Bring down the 4. 4 times -2 is -8. Then I add 5 and -8. Multiply -2 and -3. 30 plus 6 is 36. Multiply by -2, you get -72, -27, +54, and a remainder of 0. Looking at the depressed polynomial, I can tell that grouping will work, because if you multiply that by 9, you get that. So since the ratio is the same, we can do factoring by grouping. The original degree was to the 4th, so now it is to the 3rd. From the first group, I can take out x squared, which leaves 4x minus 3. From the second group, I can take out a 9. So if I solve this one, I get x equals 3/4. And if I solve this one, I get plus or minus 3i. The original degree was 4. We only have 3 solutions. Let's not forget the one that we guessed. The one that we guessed was -2. Okay, that's it for this lesson.